Hey guys, I just wanted to give you a quick Mathematica tip on how to do some of the homework in this unit. So I'm going to be looking at section 2.2, the first problem, so that's 2.2.1, the problem that we're working on. And this problem, in Unit 2, we start to work with 3D coordinates and vectors in 3D, which is kind of fun. So in this problem, we've got vector A, which has a point, the point for vector, the vector is defined by points A and B, and we have point A at 50, 90, -10, so x, y, z, and then point B is at x equals 80, y equals -10, and z equals -25. And they want us to find the position vector, the distance between points A and B, kind of a magnitude, and then also a unit vector. So to do that, I'm going to show you how we can do that over here in Mathematica. First thing I would do is set up my vectors A and B, and not vectors, I'm sorry, I keep calling them that, my points A and B. And I've done that up here for the same problem but for different numbers so that you can kind of follow along or stare at that if you want to while I'm talking. So I'll set it up down here again. I'll call it A1 this time is equal to, and for points like this, and technically in Mathematica this is a vector, so that's one reason I keep calling it that. But for that in Mathematica, instead of using a square bracket, we're going to use a curly bracket on the inside and the outside. And then I'll come in and just put the points in, 50, comma, 90, comma, -10. And I can suppress the output with a semicolon, or I can not suppress it and hit Shift Enter, and it establishes that as my first vector, my first point, whichever you want to call it. B2 will do is, of course, 80, -10, and -25, curly bracket, and I'll suppress this one. So it's still defined, but it's not output. So first thing we want to do now is get our position vector. And like Brother Miller in the movies reminds us, that is going to be the x coordinate from the second, or the head, so B, minus the x coordinate from A, the first point. So you have x minus x, y minus y, z minus z. The nice thing about Mathematica is if I have it all set up in vectors and I tell it to just subtract one vector from the other, it does that for me automatically. It'll take whichever one I say first minus the other one, it'll take the x, y, and z and subtract one from the other. So if I say B1 minus A1, it's going to take the BX value, 80, and subtract 50, and then it's going to take -10 and subtract 90, and it's going to take -25 and subtract 10. So let's see it work. Oh no. I called it B2. That's my problem. Sorry. So I can either go up here. This is one nice thing with Mathematica too, is when you make silly mistakes like me, you can go back and I can either change this to B1 and redefine that, and then look, that turned from blue to black. Which was B2 before, turned from blue to black, and now when I hit Shift Enter, aha, now we have 80 minus 50, 30, -10 minus 90, that's -100, -25 minus -10, -15. Perfect. Okay. So then I can go up here and enter those because that is my position vector now. So 30, -100, and -15. So now I want to find RAB. And RAB is the magnitude, or the distance between points A and B. It's not technically the magnitude. We'll talk more about that later. But it's the distance between those points. And this is the same as in 2D. All we do is skip the Java update because we don't like Java updates. And so we do Control-2 to get this radical symbol. And then we're going to take 30, which is our x value, and Control-6 gets us the power. We're going to say squared plus -100 power squared plus negative 15 power squared. So quick question on the magnitude or the distance here. Do we care if it's positive or negative? Not really. So if I hit Shift Enter, it's going to give me an imaginary answer. Even if I say //N, that gives me an approximate answer, because sometimes Mathematica is like your math professor and they want to see things in the perfectly accurate form, which might be symbolic. We don't really want that. We want it approximated for us. So we put //N after things, and that gives us a decimal type answer. But this is still with imaginary numbers. To get rid of that, we can just get rid of these negative signs under a radical, and then hit Shift Enter, and look, we get a magnitude, which is what we actually want. So we'll do 105.475, and that's RAB, which is great. So now we want to get the unit vector. So the unit vector, luckily they set up this problem nice for us, is actually just the position vector divided by the magnitude or the distance in this case. So all we're going to be doing is taking 30 divided by 105, negative 100 divided by 105, negative 15 divided by 105. So let's do that here. Let's take 30. Let's actually spell it out. Let's say U, A, B, and this is going to be the x value, is equal to, and I'll hit Control / to get a fraction, and we'll do 30 over, and what I should have done up here was said R, A, B, distance or something like that, given it a variable name, so that now down here all I can do is say RAB distance, and it gives me, all of these are going to be fractions between 0 and 1, as you can probably guess, because everything is divided by something that's slightly bigger than it. So 30 is less than 105, 100 is less than 105, 15 is less than 105. So they're all going to be numbers between 0 and 1, or 0 and negative 1. So we got that one, and we'll say UABY is equal to, and another nice thing about Mathematica is I can just copy and paste. I can copy that and say negative 100, I get negative 0.948, and now I'll do the same thing down here, UABZ equals, and put in the negative 15, and look at that, negative 0.142214, and let's see how we did. Whew, we got them all right. Nice.